super cool to see how all of these different pieces like open metadata as part of giving this context together with the AI agents, helping non-technical people to actually dig and build on all of these things. It's, I don't know, I think that we are living very exciting times. And I think that this idea also of empowering users to expand and have this AI give us the necessary tools and automations to keep building and keep creating kind of marries quite well with the presentation that we have here at hand, because on the past few meetups we have been discussing about, we have these open metadata standards, everything is built on top of this standard, this is super cool, this is super important. So today I actually wanted to take the chance to dig a bit deeper into how this standard is implemented, even where you can find it, and how we can even exploit it to keep expanding and keep building on top of open metadata itself. And we'll just give you a little example on how I was just able to create a new connector completely hands-off, just prompting, testing, giving the tracebacks back to Cloud Code, and how in the end everything kind of was nicely integrated together. And in order to do so, let's just start with a bit of the backstory here, right? Because in the past few years, both data and the data landscape complexity kept growing and growing and growing, not just from the transactional tables, but how this data is moving to data warehouses, using ETL tools into your dashboarding systems that then are also presenting the insights from ML models. And we keep adding new ingredients into, let's see, a bit this little madness that we have in the data landscape now with AI agents, the MCPs, the LLM providers, and whatnot, right? And that's basically what we have been pioneering with open metadata in the past few years is, okay, how can we make sense of all of this scattered information? And that's actually a very complex task because metadata is everywhere, but every tool defines it differently. Every tool shows it or makes it available in a different way. So making sense of, in order to make sense of all of this information, what we have done is, okay, let's sit down, let's just start from first principles, and let's design and implement an open source metadata standard, which basically will let us effectively translate and curate every little unit of your data platform, regardless of which system they come from. In the end, if I'm talking about a table, I don't care if this table comes from Oracle, MySQL, Postgres, Snowflake. It's a table. It should have a name. It should have some columns. It might have constraints. It might be related to other tables in any other shape or form, right? So we just need to make sure that we can gather all of these ingredients. We can translate these sources into the open metadata standard, and by keep building and integrating and relating all of this information together, our result is a unified metadata graph that helps you cover your entire stack and that empowers then yourself and your team with the ability to discover, to convert your data, to make sense of the lineage, to implement the data quality, to build your data observability standards, right? So open metadata is this implementation, this API and schema-first implementation of this standard that helps us continuously integrate new and new and new sources to make sure that we can cover the full data ecosystem. Now, if we now take a bit of a lens and dig deeper into the shape of this standard, we have developed it using JSON schemas. And one of the biggest benefits that it has is first, that it lets us define the necessary properties of each of the entities. So I was just saying, no, tables should have a name, or in this case, a user should have a name, it should have an ID, it should have an email, it might belong to a different team, it might own certain pieces, right? So it helps us define all of these properties, as well as the necessary restrictions or formats that each of these properties need to follow, both at a human and machine readable format. And what is super interesting here is how we can actually use these JSON schemas to define the shape of the entity. So if you, at any point in time, want to go into our GitHub, we have this open metadata spec directory where you can find the shape that we have put to tables, to databases, to pipelines, to topics, to database services, to the actual shape of how do I connect to MySQL or Snowflake. So we're putting together all of these basic ingredients in there. But the most interesting part here is that we can also define the relationships between these pieces. So here I just extracted a little piece of our table JSON schema, and I can see that in the end, when I'm talking about tables, I should talk about schemas. I should talk about databases. I should talk about services, because in the end, if we just take this example of our tables, I would have a database schema that contains my tables. And then my tables will have certain data quality tests associated with them. And then I will have a user or a team that owns these tables, that owns these tests. So in the end, this standard helps us cover not only how each asset behaves individually, but actually what role it plays in the bigger scheme of things. Basically, it's just building up and defining this knowledge graph that in the end helps us, again, empower the discovery, the lineage, the governance, the observability, and whatnot. So we have these JSON schemas. This is our single source of truth. And what I find kind of super cool and super useful about this standard is that it's not just documentation. It's the single source of truth. And this is literally driving the entire platform, because I have one JSON schema that will be cascading through different layers. I'm going to automatically, from these schemas, generate Java code, Python code, JavaScript code for the UI. It will encode the data that we're storing into the database. It will help me build all of the necessary documentation about our APIs and whatnot. And this is thanks to JSON schemas having excellent support, letting us remove a lot of this boilerplating of generating this code. And what it's even more important here, it drives how we are defining all of these elements, so that the backend APIs, the data, the UI, the ingestion framework, everything that we're building keeps properly aligned without drifting. So the same way that I can treat the shape of a table into my backend, I know that the shape is going to be the same when it's referenced in the UI, when it's ingested via the Python code. And this is our next step here on how I can even take this JSON schema and automatically, like if you've been playing with OpenMetadata already, I'm sure that your first step was I have to connect something, so we can even create these forms for the connection, absolutely everything driven by the JSON schemas and the standard. And this brings me to our ingestion framework, right? So when we're talking about the ingestion framework, we're talking about the core piece, this Python package, this Python module that will interact with external systems. Okay, you can think of it as the translation layer, in a sense, between the external world and OpenMetadata. And it's actually one of the most important, one of the core pieces of the entire platform, since absolutely every company journey will start here by bridging their data platform into OpenMetadata by leveraging this ingestion framework, that it knows how to connect to your sources, how to process this data internally, and then send it to OpenMetadata using the APIs. And this framework takes care not only of the, let's call it the metadata journey, but it's also the foundation of our profiling capabilities that we have built in-house, that we have also been defining with these JSON schemas, of our lineage, automated extraction, of our usage, of our data quality agents, of our auto-classification agents. Absolutely everything is driven and defined by the ingestion framework here. Now, if we keep building layers of interesting things, one of the pieces that I love about being able to build this ingestion framework on top of this standard is that, okay, I have a set of rules, right? I know that for my ingestion to work properly, there's certain conditions that I need to follow. Again, it doesn't matter if I'm ingesting MySQL, Postgres, Oracle, or Snowflake. There is a set of rules that need to be there. I won't be able to ingest my tables until my database schemas are there, since they have this internal relationship. And I won't be able to ingest my databases until these schemas are there for the exact same reason. So there's a hierarchy that we need to follow. And the beauty of this is that these standards and relationships are the same for every table, for every schema, for every database, regardless of the origin. So we have built the ingestion framework in a way that helps us really translate and curate every different little system that we want, which means that once we have our connectors defined, once we have our pieces part and integrated of the ingestion framework, we can take care of, let's call it the complicated parts, right? The not so much business-centric parts of how do I treat Postgres data. I don't care about that. The Postgres connector will take care of it. Now I can just really take that little Lego piece, put it together with my broader framework so that OpenMetadata can take care of how the user will connect, it will fill the form, it will deploy the ingestions, it will automate and schedule all of this process, how it's going to connect to the source system, how it's going to send back this information to the user. So all of this boilerplating, all of this logic on how each and every connector fits inside the system, it's managed by this bigger framework. So if I need to go and say, okay, I actually want to add a new connector because now I'm playing with a super new cool database that's been out in the market and I want to be able to discover it, to govern it, to manage it within OpenMetadata, it's super, super easy to go and add this new connector by leveraging our ingestion framework. And let's take the next step of saying, okay, now I have this standard that defines every unit of the platform. I know that each connector needs to follow this standard. And this connector fits very nicely inside my ingestion framework. So there's all of this set of rules, all of this set of patterns that coding agents can help us in just automating a big chunk of the work. I don't need to start from scratch. I don't need to kind of bang my head against the wall trying to make sense of all of this framework or the internal pieces on what best practices or how the scheduling is actually fitting in the system. I can just let the AI systems, Cloud Code Cursor, whatever it is that you're using, manage the bulk of the work in there. So what I'm going to show you now is a bit the different steps that I took here in order to create a new connector. In this case, we were missing a connector for QuestDB. I was just literally surfing around trying to figure out what might be interesting to add. And this QuestDB is kind of an open source database that helps us with time series analysis. So looked quite cool, right? So I spun up this QuestDB directly in Docker. I have it now running in my system. I created a few tables. There's some data in these tables, like nothing crazy. I'm just really trying to make sense and join all of these different pieces. But I have already my database going in here. And actually, if I want to start building on this, now that I have my database up and available in my system, I don't even need to start from scratch. Because one of the things that we also have is a scaffolding ability. So we were talking how I have this schema, I have this structure. So I can even help the agent even more by leveraging this structure just directly boilerplating all of these initial files. So here I just called our metadata CLI to scaffold the connector, just passing brief information. Like, hey, I'm talking about a database. I know that this database is going to be based about SQL Alchemy connector. This is the scheme that it's going to use, the kind of authentication. So I can also let Claude figure this out for me. But in this case, since it was rather simple, I just went ahead and called the CLI myself also so that you could see all of the different steps, all of these different helpers that we have been providing that you can leverage. And once I had this scaffold there, I just started the conversation with my best friend Cloud Code, and I say, hey, just use these scaffolding files and build the QuestDB connector for me. And as you can see, it's the first thing that it said, I'm going to load the connector standard skills. Because something that we have built together with the Ingestion framework is saying, okay, there's a lot of lessons learned that we gathered in the past few years of building and improving every little piece and corner and edge case about the Ingestion framework. So we have been coding down and documenting all of our standards, templating, examples, everything that the AI can leverage in order to actually go here and start helping us build a connector from how we can manage the actual connection object for SQL Alchemy pieces on good practices on how we can load metadata or how we can access the source systems, dividing with between anti-patterns, correct approaches, how can we make sure that the performance is going to be up to the bar of what we need. So in this case, it's leveraging on one hand all of the lessons learned properly encoded and defined in these different skills about how do we build a connector, how do we define the standards, even how do we review that the connector that we have built actually properly follows all of these little things and pieces. And the end result of that was me just playing around. As you can see, I also hit some walls along the process, like I was trying to test the connection, something was not working properly. I literally just copy paste the message to Cloud Code, let it figure it out. And the final result was a nicely shaped PR with some of the changed files here that are defining how the connection object is going to be looking like. It even helps me defining the tests, which I think that it's brilliant, being able to automate some of these pieces. And how am I going to test the connection? How am I defining the connection, the actual connection object that we're going to use in here? So I literally did not write a single line of code. I let Cloud Code kind of figure it out, our good, best practices from these skills, together with everything that we have been building and encoding and managing on top of this Open Metadata Standard. And here you can see a bit the result. I have my QuestDB service. I can test the connection. This is going to go then send this information to Airflow, give me thumbs up. I can go back to the agents, play a bit with the metadata, make sure that I have all of the necessary information, and I was able to ingest these 4 tables that I just created for my sample. And before finishing here, if you want to have some fun and build that lovely connector that you would like to see as part of the Open Metadata, just some tips and tricks. First of all, please do check the docs, because actually we built something quite cool together with these skills. We have docs on how you can actually develop a new connector. It's going to guide you on how you can manage these skills, how you can actually set up this AI-assisted development. So we really want to make it as easy as possible, as simple as possible for everyone to share the joy of collaborating and building and contributing with Open Metadata. The second is understanding the architecture of the project is always going to help you if you can figure out the different pieces. Okay, so I have the server, I have the ingestion framework, I have Airflow that it's going to be managing all of these things. Will really organize all of these ideas. And then finally, you can also quickly iterate using the metadata CLI. So if you don't want to keep rebuilding Dockers, which sometimes gets a bit tiresome, just to try every little thing. Just remember that the same way that we have this metadata CLI to help us scaffold things, you can also run the CLI to help you ingest the metadata just by passing a simple YAML such as this one, and it's really going to help you just go super quick, copy paste the logs to Claude, let it continue to iterate until you have that nice and shiny connector on a PR that we can go and review for you. So yeah, that's everything that I wanted to show. Exciting times, all of these properly driven by our standards, by the lessons learned of the ingestion framework, and fully encoded in these cloud skills. So thank you all, and Nick, back to you.